Hi everybody, my name is Firmin and I will be your Snapask Geography tutor. Welcome to this geography course, and I believe that over the course of this term, you and I will discover the wonders of the world we live in geography. So the Earth's interior has a layered structure, right? You can see from figure 1.1. So each layer has different physical properties. And these three layers are called the core, the mantle, and the crust. Now, to illustrate this three simple and basic layers of the Earth, I'm going to use an egg, right, to show you the different layers of the Earth. So we know that an egg has a shell layer. So if I take out the shell, right, so you can see, you crack it, there are different, size of the shell, right? So the shell is known as the crust of the Earth. So once I completed taking out all the eggshell, what we can see is actually the egg white, right? Now, we all know that the egg white is actually the thickest layer of the egg, right? It forms bulk of the egg, just like the mantle. So the egg white is actually a representation of the mantle of the Earth. Now, once I clear out the shell and when I cut out the egg white, what you see is actually the egg yolk, right? So the egg yolk, this yellow ball thingy inside the egg, in the middle of the egg, is known as the core of the Earth. So you can see that in this egg, we can see that there's a crust, which is the shell, which is the crust of the Earth, the egg white, which is the mantle of the Earth, and the egg yolk, which represents the core of the Earth. Now, in each of these different layers, there are different physical properties. So we're going to move on in understanding the properties of each of these different layers. So fundamentally, the reason why the plates move is due to two processes. And these two processes are known as convection currents and slack pull force. Now let me explain. In science, right, we learn about convection currents. We learn about hot air rises, cold air sinks. Why is it that hot air will rise? It's because the heat will warm up the air. The air molecules get heated up, it expands, and it rises. It gets lighter. And that's how your hot air balloon functions, isn't it? Right? You need that heat there to cause the air molecules to rise. But as it rises up, okay, it will cool. And when they cool down, the density gets heavier, increase in density, and it sinks down again. Right? So therefore, when we learn about convection current, we understand convection current with this circular motion that goes around. Great. Now, put this understanding into the mantle layer. Now, we all know that the core of the Earth, right, is the hottest part of the structure of the Earth. So the heat from the core, all right, will warm up the magma in the mantle. So the magma that is nearest to the core will get heated up. And once it gets heated up, what happens to it? It will rise, it will expand and rise up, right? It will rise up like this, okay? Rise up here, okay? As it rises up and when it reaches beneath the crust, so the distance now is further to the core. What it means is that the temperature of the magma will be lowered, will decrease, right? So as it reaches to beneath the crust, what happens is that it will spread out like this. It spreads. Now, imagine when you have two opposing force that goes in two directions. It's like tug of war, right? When you pull in both directions, what happens is that there is this thing called a tensional force. So this tensional force will cause this part of the crust to be pulled on both sides. Now imagine, if you have a piece of rod and you try to pull it, or a pencil cap with a pencil and we pull in both directions, what happens? There will be cracks will happen and then there will be a gap. right? So this pulling of opposite direction is what we call a divergent movement. A diverge, where plates move away from each other. Okay? Now, as it moves up, both this way, okay, this magma will start to cool down. And once it cools, what happens? It will sink. Right? It will sink. So if we look at both sides of the diagram, okay, both sides of the diagram, right, it will sink down. So as it sinks down, the magma will, the sinking magma will then cause two plates now to collide because they are now moving in the same direction. Okay? The previous one was the magma spreads out in opposite direction, causing the plate to diverge. On the other side, now the magma, the cooling magma is sinking and both sides are coming together and therefore there is a collision. Okay? And the cooling magma will force the way, will pull down the crust. And that is what we call the slap pull force. The slap pull force. So as the cooling magma sinks, when it sinks, what happens to it? It goes nearer to the core. Once it is near to the core, what happens again? It gets heated up. It gets heated up and it will rise. So that is how. So this repeated action of rising and cooling actually causes the pulling and the pushing of the plates. When there is a pull, there is a movement. When there's a push, there's also a movement. Right? So this is how the plates actually move. Sometimes exam requires you to know how to sketch the formation of a reef valley and a block mountain. So I'm going to go through with you the step-by-step learning of how to sketch the formation of a reef valley. Okay, so take out your pencil, your pen, alright, on this page, I want you to draw it together with me as I go through with you. Okay, first and foremost, first diagram, we will draw like this. Okay? This is your crust. Okay? This part here is where you stand. Okay, I'm standing here. Should I just beautify it? No, I think it's okay. You'll look ugly later. Okay, so with a piece of continental crust, okay, remember when we talk about divergence, what kind of force is there? Tensional force. So there's tensional force on the crust. Okay, there's tensional force on the crust. Okay, it's pulling. With repeated pull, what happens? Is that, okay, same thing. Right, with repeated pull, what will be formed? Cracks and fractures are formed. Like that. Right, I'm still here. Okay, that's me. Alright, so cracks and fractures are formed, right, with repeated pull. Keep pulling it. Now, again, with continuous divergent movement, the cracks will get bigger, right? So when you have bigger cracks and all, when you keep pulling it, now what do you think would happen to this middle portion? What will you think will happen to this middle portion when I am standing on right now? It will eventually sink. So it will become like that. Okay? So it will sink. So this sinking part here, this part that has the piece of what used to be on top and now is sink down, alright, is what we call a reef valley. A reef valley. Okay? And the two pieces of highland that flanks the left and right of the reef valley is known as block mountain. Okay, sorry, you need to write down tensional force here. Huh? Okay? So this is how the three-stage formation of a reef valley on a continental plate boundary. How a reef valley is formed and a block mountain is formed. Alright, so in the previous slide, we hear that at the Reef Valley, now please do not have a myopic understanding and view of the Reef Valley. In the actual real life Reef Valley, it is wide, it spreads across a huge area. Okay, and as mentioned in the previous page, volcanoes can be formed on the Reef Valley here, like this. It's possible. Alright?